Hey guys, looking forward to hear your presentation.
Hi, Prof. Thanks so much.
Yeah,
Thanks, bro.
I've told my master's classes about you guys. So they are, I don't know if they'll come, but at least they are aware. And very cool of the cool stuff you guys are doing. So exciting. All the best. Start strong. You will do great.
Thank you so much.
Hi guys, thanks for coming to the talk. We'll start at 2:05. So please be patient until then. Thanks.
Okay, I think we can get started now. So hi everyone, and good afternoon, and thanks for coming down at this time. So we are from the blockchain department of NUS FinTech Society, and today we'll be presenting to you our project over the past semester, which was where we created our very own DAO organization. So a little bit about us before we get started. So I'm Vimuth. I was looking over the research aspects while Jung Xiong took care of the entire front end, and Bryan was working on the back end. So I'll basically walk us through what exactly a DAO is, how it operates, and some of the advantages and disadvantages, basically to get everyone on the same level and understand what exactly a DAO is, after which Jung Xiong and Bryan will take care of the technical aspects of the project. So firstly, what exactly is a DAO? Well, I think most of us here already know that one of the biggest selling points of blockchain is the fact that it's decentralized. So what a DAO does is essentially we're bringing that into the context of organizations. So what do I mean by that? It's basically, so a traditional organization has a typical management structure, right? So what we're trying to do is we're trying to abolish that by kind of allowing the entire community to have a say in how the organization moves forward. So this leads to a sort of no central leadership and means that any decisions that need to be made just get made by the entire community. So there's a specific set of rules that are enforced by the code that is on the blockchain. So even these rules are not controlled by the members, and so there's no influence by any central entity. And this essentially leads us to not requiring any managers and removes any bureaucratic or hierarchical hurdles that we had in traditional organizations. So that's the main gist of what a DAO is. And let's look at from a high level how it actually operates. So at the very beginning, there's a group of people who write the smart contracts. Now the smart contracts are it's basically the code snippets that control and set the rules and policies that the organization will abide by when it's active. So, well, in this context, that group of people is us. And once the smart contracts is set up, there is an initial coin offering. So an initial coin offering is basically a sort of funding period. This is where the people add funds to the DAO by purchasing tokens to represent ownership. We can call this a crowd sale. And what it does is kind of give the DAO the resources it needs to continue. So once the funding period is over, the DAO actually begins to operate. Now anyone, so people, members of the DAO, can make proposals basically on how to spend the money, how to manage the funds, decide the direction of the DAO, the objectives, and anything that is within scope. So once these proposals are out there, anyone who has a say in the DAO get to vote on this, and any approved proposals will go through. So that's the essence of a DAO. And now just a quick dive into the history of how the DAO actually came into being. So the very first DAO, which is actually called the DAO, came into being in April 2016. So it was actually a venture capital fund, and it was a crowdfunding campaign via a token sale. And it actually became one of the largest crowdfunding campaigns in history. Now, this DAO had one objective, and it was to provide a sort of decentralized business model for organizing both commercial and non-profit enterprises. It began on the Ethereum blockchain, and like any DAO, it didn't have a conventional management structure. Now, in June 2016, what happened was users actually managed to find a vulnerability in the code because it was open source, and they exploited that. And this basically the DAO was hacked, and a third of the funds were moved to a subsidiary account. This was when the entire community decided to actually hard fork the blockchain at that time. And in essence, virtually all funds were restored, but the blockchain was broken into two branches and with its own cryptocurrency. And the original one continued as Ethereum Classic. And what happened afterwards was September 2016 came, and the entire DAO just was delisted from cryptocurrency exchanges, and it became defunct. So that was back in 2016. And what we see was, I think last year, there was a new explosion of DeFi and a lot of interest around that. And with that explosion actually came renewed interest in DAOs. we can see that from, I think recently, even Reddit started implementing this community-wide points system, where where you based on the forum you're in, the subreddit, you get a sort of token. And with the more tokens, the more you can vote on and have a say in how the forum runs. So now let's get down to what benefits does a DAO actually bring to the table. So first off, I think the very primary reason for the existence of a DAO, right? By removing this sort of hierarchical structure, we're removing any drawbacks that come with. So I think one of the main problems with this existing structure that we have is that, well, to say it bluntly, how it works is that any contributions that come from anyone who isn't at the top of the pyramid get invalidated. So that's one of the major issues, and everything else kind of follows through from there. So secondly, like I said before, anyone who is invested in the DAO has an opportunity to shape how the organization is run. So this also comes into play because in all the rules and policies that are pre-arranged, any stakeholders have access to these principles. So before making that investment, they can actually look into this, see how the DAO is meant to be run, and actually take a holistic decision before making their investment. So once it's established, the rules just are carried out. So everyone has an opportunity to actually submit proposals and have a chance at giving their ideas out. Thirdly, thanks to its autonomous structure, there won't be any squabbles or power plays within a DAO, because any stakeholder at any level can submit a proposal, any idea for improvement. And I think the important part here is that the consideration of these ideas is not sort of consigned to boardroom or sort of management that is out of touch with its shareholders. And fourthly, proposals will usually be well constructed coming in. Why? Because it costs a bit of money to make such a proposal. I think this is a good advantage, because we eliminate any ideas and proposals that are just nonsense or spam. So in general, this makes it a way more efficient organization. And finally, as with mostly anything on blockchain technology, transparency is key. And when it comes into the context of organizations, it becomes even more important, because once you can see the entire history of an organization, how it does function, how it manages funds, and basically any decisions they have taken, you coming into this DAO can make a very holistic decision. So everyone coming in bears the same responsibility. I think that's one of the very key advantages of having a DAO. So a look into the downsides, a few of the downsides. I think from the example I gave with regards to the 2016 DAO, I think one thing we need to learn is any DAO is only as good as the code, right? So if the code has any vulnerabilities to be exploited, they will be, and it will lead the DAO to fail. So there's a major dependency on the security of the code. Secondly, there's also ideas that it doesn't always make sense to give control to so many investors. For example, in the context of finance, even institutions like MIT have brought this up, that the world is just not ready to sort of have everyone given a say in decisions of our organization, which is true. It does not, at least at this point in time, DAOs are still in infancy. It does not make sense to apply these ideals to every single corporate context we have out there. And finally, and personally, I think one of the biggest drawbacks of a DAO is the fact that regulatory uncertainty holds the development of DAOs behind. I think if you look at, again, if you look at the 2016 DAO, what we see is it was a crowdfunding contract. At least that's what they claimed to be. But afterwards, when the SEC began an investigation, they determined that it did not meet their requirements. And because it was not a broker-dealer and it was not registered with the SEC either. So this sort of, lack of legal personhood prevents DAOs from doing very basic things like owning property or entering into most legal contracts in most jurisdictions. So this should be the biggest limiting case in typical corporate purposes. Okay, so that was a lot of information about DAOs. So hopefully everyone is on the same level as to what a DAO is. So now let's dive into our project. So our DAO is actually called the ABC DAO, and it stands for a blockchain DAO. So our ecosystem is, at least as of now, it's meant for members of our department. And right now we don't, we're not trying to attach any value to it, at least at this point in time. So the token in circulation is called the ABC DAO. So coming into this project, we had three main objectives. And the first of which was obviously for educational purposes. We wanted ourselves, as well as all of our members, to get exposed to how a DAO works. And I think it was a pretty good venture, and we actually did learn a lot, and our members will too. Secondly, we're going to use this DAO as a tracking system, where we are sort of incentivizing members to contribute more to our organization. And by doing so, they will be rewarded with tokens. So the more the tokens, the more say they have in how our department will run. And thirdly, yes, the benefit that comes with having a DAO is any votes that need to be taken will be democratized to a certain extent within our department. So those were the reasons we embarked on this project. And I think we can pass time to Junxiang to talk about our front-end design.
Okay, thanks, Vimuth. Okay, so now we know what a DAO is and how it functions. So maybe let's talk about some of the design and decision-making processes that we went through while creating the front-end and back-end components of our DAO. Okay, so I'll be covering the front-end side, which was built using React, Tailwind CSS, and Headless UI, as well as using some of the Open Zeppelin APIs and IPFS technology. So I'll be going through the Open Zeppelin APIs and IPFS technology, and Bryan will be going through the backend code, which was in Solidity. Okay. So the state of the web as we know it today is currently at Web 2.0, and it signifies an internet that is mainly dominated by companies that provide services in exchange for your personal data. However, in the new web, which is Web 3.0, we are trying to shift towards a web with more decentralized apps that run with the help of blockchain technologies. So these can include services, AI-driven services, decentralized data architectures, and as well as edge computing infrastructure. So in our use case, we use Web 3.0 as kind of a decentralized web backend, which can also function as an open, trustless, and permissionless network. So to clarify what open, trustless, and permissionless is, open just means that it is built from open source software, which has an open and accessible community of developers. This also means that everyone can view the code as they please, and there's no hidden secrets inside the code. Trustless means that the network itself allows participants to interact publicly or privately without a trusted third party. So basically anyone can interact with this network. And finally, permissionless is that anyone, both users and suppliers, can participate without authorization from a governing body. So in this case, the governing body is a fintech society. Okay, so by using the Web3 APIs, Web 3.0 APIs, we can actually connect to our IPFS servers through HTTP protocols. And this, in essence, helps us use Web 3.0 as kind of a decentralized database. So in this case, the first red circle is our Web 3.0 APIs. So what exactly is a IPFS system? So IPFS just stands for the Interplanetary File System, and it is a local peer-to-peer storage network. The content is accessible through peers located anywhere, and they can relay information, store it, or do both. So basically this interplanetary, sorry, there's somebody who is, yeah. So basically this IPFS system works by assigning a unique ID to each item based on its content, and has actually transport encryption to secure data when it's moving from one place to another. So it's relatively secure, and there's nothing for us to do other than to encrypt the data that we send to the servers. Okay, so how do we actually use IPFS? So we use IPFS in our project as a peer-to-peer database. So in this, by doing this, we manage to store information about proposals, votes, and user data, all in the decentralized blockchain network. So in this case, we use Infuria's APIs, Infuria's IPFS built-in APIs to store the data for us. Okay, so let's talk about some of the choices that we made with the ERC tokens. So to begin with, let's explain what an ERC token is. So ERC just stands for Ethereum Request for Comment, and it's actually just a it's kind of a framework that was made for tokens and was implemented in 2015. So digital assets that are built on top of the Ethereum blockchain are also known as ERC tokens, and they all have the same properties. One of which is that it's a fungible token. So fungible just means like the same, and you may have heard this from NFTs, which are non-fungible, but in the case of ERC tokens, they are actually fungible, and it just means that they are exactly the same in both type and value to that of another token. So for example, a ERC token acts just like the Ether, meaning that one token is and always will be equal to every other token. Okay, so this particular token also helps to empower developers of all types to help accurately predict how new tokens will function within the larger Ethereum system. So you can see how this can benefit the system, since this simplifies the task that is set forth for developers. So they can proceed with their work without knowing each and every new project will have the same framework and won't have to be redone every time a new token is released. So as long as the token follows a set of given rules, that is. Yeah. And in this case, our fungible token can represent anything, such as fiat currency like USD, shares in the company, or gold, or scale levels even. So yeah, and this compliance of rules is very necessary because it helps ensure compatibility between all the different tokens that are issued on a network. Okay, so let's talk about some of the tokens that exist currently, one of which is the ERC20 token. So ERC20 token is one of the most popular tokens and is widely used in many applications, the most common being Ethereum. So some of the rules that the ERC20 token has to follow and has to comply with for it to be a ERC token is that number one, it has to have a total supply, which will just provide information about the total token supply at any given time. Secondly, it has to have a balance of, which is to provide the account balance of an owner's account. Thirdly, it must be able to be transferred. So it executes a transfer of a specified number of tokens to a specified address, and also must be transferred from. So this also just means that it has to execute transfers from a specified number of tokens to a specified from a specified address. So it will get some amount of tokens from address, and also it will also have to allow approve and allow a sender to withdraw a set number of tokens from a specific account. And finally, it has to have allowance. So this just means that it will return a set number of tokens from a spender to the owner. Okay, so all these functions will also trigger two events, which are called the transfer event and the approval validation event. So a transfer event is when activated it's just activated whenever a token is transferred, and the approval validation event is just activated whenever approval is required. However, in our case, for our DAO, ABC DAO, we did not choose to use the ERC20 tokens, and we'll explain why here. So some of the downsides of the ERC20 tokens is that the ERC20 tokens can be sent to any address. So in this case, because it can be sent to any address, it can also be sent to a date address. And in that case, where we send the tokens to a date address, it just means that the tokens will be locked away forever, or it will be we can't retrieve it anymore. So secondly, it also is not traceable. So any tokens that are manually moved, we can't trace from whom it came from and for who it was for. So yeah, it's very hard to try to send the tokens back. So this is why the ERC20 token also has the approve function, which helps allow the approval of transferring of the contract. But this is also very troublesome since we need 2 transactions for every ERC20 tokens. So sorry, I'll just use this picture over here. So every time we make a call, looking at the picture to Alice and Bob, we have to call the function twice. So one is the transfer from function and one is the approve function. So this obviously has a few downsides in that we need 2 transactions for every token, and Secondly, it's also not very feasible sometimes to have two transactions, since users will be interacting with another smart contract, which may hold the tokens and releases them from the back to them. So yeah, assuming that this is not a lost vote mechanism, later which will be explained later. So since ERC20 tokens cannot be upgraded, and also cannot be traced, it's very hard for us to, if we were to use ERC20 tokens, we will have to deal with these issues forever. And since we didn't want to deal with that, we chose the alternative, which was to use another type of token, which was ERC777. So ERC777 basically is very similar to ERC20 by nature, in that they have very similar functions. They enable the execution of, however, they enable a certain execution of certain functions in one transaction. So remember how ERC20 tokens can get locked away? ERC777 allows us to recognize unsuitable smart contracts or addresses where the tokens might get lost. So not only that, it also allows us to transfer tokens without having to do two transactions, which was the main issue with ERC20 tokens. So after the operator is authorized by a sender in the ERC777 token contract, the sender can actually send the tokens to the receiver through the operator. So because of this, the sender does not need to pay any gas, and the gas will instead be paid by the operator. The gas is basically the fee, the cost of transferring a token. So, but since ERC777 token is not very widely used, because it's kind of a newer contract, ERC framework. So many legacy smart contracts which are not upgradable are non-compliant with the ERC777 standard, and it makes them very hard to upgrade. So that's why ERC777 is not very widely used. Okay, so I'll just give you all a quick demo of our app right now. So this is just the front end directory that we have here. So currently, our app is still in alpha, so we only have a few directories, which is the root, the vote, new proposals, proposal IDs, and the profile. So let me just walk you through the app right now. Okay, so when you come to our app, you'll be greeted by the dashboard page. And yeah, for now, we just have it deployed on GitHub because this is our, this is just our temporary deployment page. Okay, so for now, when you enter, you'll reach the dashboard page, which just have some information about blockchain and stuff. So first of all, we will be prompt you to log in to MetaMask. So MetaMask is basically a wallet for cryptocurrencies, and we require you to have MetaMask because we have our own DAO coin, right? So we kind of need you to have MetaMask to be able to store your coins. So I'm just going to go ahead and log in. So this is my account for MetaMask. Okay, so going to the vote page, we see we have many different proposals that I use for the testing network. Yeah. So let's just go ahead and create a new proposal now. So I'll just name it hello, and maybe put test here. And I have two options, 1 and 2. So for the sake of the testing, we'll just use loss voting for now. But later we'll explain what loss and allocation proposals are. And also I'll just set a minimum stake of 5 coins and maybe put the end date to Wednesday. So yeah, I'll click publish. And upon publishing, we will get a MetaMask notification asking us to pay some amount of gas fee. So this gas fee is what we have to pay in order to make a proposal, like what Vimuth was mentioning earlier. So because we have to make this small payment, people will be not incentivized to just spam proposals over and over inside our current inside our blockchain. So I'm just going to go ahead and confirm that. Yeah, so once I click the confirm button, what is basically happening is the IPFS hash is being made, and is the IPFS hash of the data is being made, and the data will be wrapped inside the proposal. Then afterwards, we will call the smart contract. I'm not sure if you all can see, but I got a transaction confirmation. So the transaction is done, and we should see it appear here. But yeah, basically the data will be sent to the IPFS servers, and it'll be posted and grabbed by this API over here. So now we have the data over here. So this is the test I just created like a few seconds ago. And let me just go ahead and cast a vote. Oops, need to have a vote more than 10. So I'm just going to vote on option 1 with like 10 of our ABC DAO coins. So once again, we have to confirm this on MetaMask. So they make me pay a small gas fee as well. And once I confirm the vote, what is happening is now that we will get the IPFS address of the current vote, store and write all the data that that we have in this particular contract and send it back to the backend contract, which will be approved by the server and validated by it. So some of the information that we have inside our contracts are obviously the author, the IPFS address, which is this address also, of each proposal. So you can actually use this address and view it in third-party software. So it's not just this IPFS is not just limited to our current website. Also, once again, the transaction has been confirmed. And yeah, and we have the minimum state value and the voting system. So of course, we have the creator and closing date as well. So let me just go ahead and give this page a refresh. And as you can see, we have the new results. So my vote has went through and I'm the only one who's voted. So they show the list of voter history. So there's no way to hide your votes in our current system. Okay, so that does it for the demo of our app. And I'll be passing my time on to Bryan, who will explain how our backend works in relation to the app.
Yeah, thanks so much, Jun Xiong. Now I'll be covering a bit about the back end of the DAO, which is basically the smart contract architecture. So using some standard object-oriented programming techniques, we have decided to create a number of scripts which all serve a different purpose. So right at the top, if you can see, there's admin control and string utils, which are basically kind of helper Solidity scripts, which abstract the simple task out from the main script, which is the voting one. So for instance, as the name suggests, admin control script only allows for admins to have control over certain functionalities. So for example, only admins are allowed to create proposals. So it prevents any Tom, Dick, Harry from just spamming and creating proposals for themselves. Then we can also see another Solidity script, which is also called DAO pool. And you can think of DAO pool like a bank for the tokens. So it can give and receive tokens. And this is very crucial during the voting phase because we need to be able to safekeep the state tokens. And additionally, depending on the type of vote that we are implementing, the DAO pool will either return or not return the tokens to the individual users. I'll be covering more on this later. Yeah. And next, we have the main script, the voting script. And this is where most of the heavy lifting is done. So for instance, the tracking of options chosen by the participants, the actual inner workings of how the voting system works, etc. It also has getter functions also to allow the front end to interact with the smart contract to get information regarding the status of the proposal, the number of votes on the individual options, and other sorts of information. I'll be showing you parts of the script later, not to worry. In a separate branch, we also have the NUS Token Script. With the help of OpenZeppelin, we actually created the Erc777 token, as mentioned just now. And it's quite straightforward because it's basically a lot of boilerplate code. We just need to import the OpenZeppelin script, and then after that, we just need to input some general information, for example, the name of the token or the number of tokens to be minted for example. Yeah. And also we have a migration script at the end, which allows us to help deploy the smart contracts we wrote to the Ethereum network, which is responsible for staging the deployment task. Yeah. Now we'll be taking a closer look at the idea behind the voting Solidity script. So as mentioned, this is where the main action happens. So we have the structs. We have two structs here. We have the vote info and the proposal info. What are structs? You can think of them a bit like classes in Java. So when we create a struct, it allows us to create our own data type in the form of a structure. So we are kind of creating vote and proposal objects. And I'll revisit this again when I show you parts of the code. And these structs help us store valuable information regarding the proposal and the vote options. And this information can be used within the smart contract in various functions like setting the proposal status or during the voting phase where the struct may be modified to include certain new information such as the option voted and the stake value. So I previously mentioned that the voting script also has some getter and setter functions. We can see them on the next slide. Next slide, yeah. You can see that we have certain getter and setter functions. For example, the getter function in this case, we can actually see the IPFS hash of the proposal itself. So on the side note, the IPFS hash, besides acting as a sort of identifier in the smart contract, is otherwise quite useless in the smart contract itself. It's mainly used on the front end to figure out the actual details of the proposal. So in the smart contract, we are only worried about the bare bones of the proposal. For instance, the number of options typed to the proposal or how many tokens have been staked on the individual options. We're not actually fussed by what option 1 actually means. To us, we just store it as index 0, yeah, and that's it, yeah. We have also getter functions to get the information regarding the proposal or the list of proposals that are currently active, etc. Yeah, and we also have certain setter functions. For example, we have a setter function to initialize the user. So maybe we don't want everyone to have the ability to vote on a certain proposal. So we can actually set certain users to have the ability to vote on certain proposals or not. Yeah, and we also have certain set of functions to like create the proposal, set the proposal status, and also like the main voting functionality. Yeah, next. Yeah, so we can see here, as I was mentioning just now, we actually create certain structs like the vote and the proposal structs. Yeah, and where they store crucial information, for example, the hash, the address of the voter, the option that the voter has picked, and the amount of tokens staked by the certain user in this case. Yeah, and we also have the proposal info, which stores a lot of information regarding like regarding the specific proposal, which we have the hash, the number of options. We also have like a list to actually store the number of users who have voted on the proposal, for instance, or like so there's a lot of information actually being stored here. There's also like certain booleans which actually store whether like the proposal is active or not. Yeah. Next. Yeah. So now we'll actually look at part of like the proposal creation function. So like given a certain like set of arguments, you can actually start creating a proposal. And as you can see here, we are basically like initializing the struct mainly. And then once we finish initializing the struct, we can push also the IPFS hash into a certain like array where we store all the different hashes of the proposals which are currently active. So this allows us to actually keep track of what proposals actually currently exist. And then we also use event emitting to actually basically indicate whether we have successfully created the proposal or not. Yeah. And next, we'll be looking at the actual voting implementation. So first, we first have to check for certain conditions. For example, like if the IPFS hash exists or not, for example, or like if the proposal is active or not, if the given stake is below the allowable stake value, or if the option index is not valid. There are a lot of different stuff that we check for. But if everything is satisfied, then we can go ahead and update the proposal and also emit an event stating like the updated vote. Yeah. Next. So now I'll be covering a bit about the various voting types. So the first type is loss versus lossless vote. And I think this is quite self-explanatory. It's basically meaning that lossless means you get back your tokens after the proposal has expired, else you will not get the tokens back. Allocation versus non-allocation vote may not be so straightforward. It's basically what we're trying to do is that we're trying to find the most voted on option, and then like the top like X number of people who have staked the most amount of tokens on each of the options will get the option. So for instance, if we have like options A, B, C, and everyone votes, then like the top 5 people who staked on A will get A, top 5 people who staked on B will get B, and so on. Yeah. So how do we intend to integrate the DAO into our FinTech department? Yeah. Well, we're thinking of actually setting a floor to the minimum number of tokens to remain in the society. So this should encourage like active participation within the society itself. New members will also get a certain number of tokens, and depending on seniority, certain members may get more tokens than others. Yeah, as you can see on the slide, junior analyst gets 1,000 and senior analyst gets 5,000, for instance. Yeah. Next slide. Yeah, so how do we get tokens? I mean, basically, the idea is that when you do projects or take part in meetings, present findings, or write articles, you'll be like rewarded in tokens as like sort of incentive. So like more tokens means also having more say in the society. So you'll probably have like a higher chance of getting the project of your choice because you are able to bid more, or like or you can even have like more say in the small stuff in the society. For instance, like when a meeting will be held, for instance. Yeah. And so what are our current goals and extensions that we are looking at? So first, we are thinking of possibly collecting data from the members, and this will allow us to have like a more personalized profile page, for instance. And we are also thinking of actually deploying the DAO webpage to the main FinTech website. We are actually thinking of having a better search engine optimization also to reduce the time required to search for specific proposals. This may be particularly relevant in the future if there are like different departments. If different departments actually decide to use this DAO, then we may have a lot of proposals, and then like actually having a quick search would be much more efficient. Yeah. In terms of the Solidity smart contract backend, we are actually thinking of ways to maybe auto-generate the tokens if necessary. We are also thinking of using contract events to get the transactions, automating the token distribution process using cron jobs, and also allowing for revoting and adding on votes. So for the last point, like right now, for example, if you vote on a certain proposal, you're not like really allowed to vote again on the same proposal, and like you also cannot rescind your vote. So like there's some like tweaking and some like more flexibility that can be added onto that front. Yeah. Okay, and before we end, we would like to have a special thanks to Adi for like helping a lot with the back end also. Colin and Lai Yuan for their guidance in the overall like big scheme of things for this project. Yeah. And thank you so much. We have come to the end of our presentation. I hope you have a better idea of like what a decentralized autonomous organization is, and like how ERC tokens work, and like in general like a better understanding of this whole process that we have created here. Thank you.
Thanks everyone for joining. And we have a few more events that are going on today. And I want to just thank again Bryan, Jun and Vimuth for coming in and sharing with you. Hope this was helpful. I'm Keith Carter, professor in School of Computing. And so with the FinTech Festival going on, today at 3 p.m., we have our Talent Pavilion discussion, which is with Member of Parliament Patrick Tay, who's also Assistant Secretary General at NTUC. He's going to be sharing all about what's the jobs outlook look like. And we also have the head of HR for UOB Bank, as well as the head of Spencer Stewart, which is a recruiting company, and the CEO of a great new company out of the UK, which is, she's going to be dialing in with us. So come join us at 3 o'clock today, day 1. So if you could move back to slide number 2, day 1. That'll be great, and this will be where you can come over. Come on over to room number 7 in just a few moments. And I think there might be some questions here. Sure, absolutely. Go ahead and ask the speakers about questions as well.
Hi, I see some questions from Nicholas. Thanks so much for your question. So how are the gas fees determined? The gas fees are determined based on like so for every, I'm not sure whether like you really understand like what gas fees are, but like basically for every transaction, which you have to actually pay a certain gas fee. So right now we are actually operating on like a test network. So actually the money isn't like real money per se. Like, it's just like money that is just, for example, with the Robson testnet, we are just basically taking ethers from like a test faucet in that sense. But let's just say if we are to like make transactions on the actual main Ethereum network, then yes, we'll be paying real money in the gas fees. And gas fees are actually determined by I say like the computational complexity of like the script itself. So that's why if like, let's just say if our smart contract script has a lot of like for loops and like a lot of like back-end things happening, then yeah, I guess the gas fees will be very high in that sense. So I guess that's the whole idea of smart contract development, is that you to try and make it like as simplistic as possible to prevent like your gas fees from like becoming astronomical in that sense. Yeah, so if possible, like, so for example, like when we save our the addresses of the different proposals in an array, and we actually like we do most of like the processing like actually on like not really like not on the smart contract itself, like, but on like a back end. Yeah, so if you do on the smart contract itself, then there'll be a lot of processing fees, and then like the gas fees will be very expensive. And you also asked like what happens to tokens for a lost proposal. Basically tokens will be just will be stored in the DAO pool. Yeah, the user will not get the tokens back. I hope this kind of answers your question. Maybe if the rest, you have anything to add to this?
Yeah, no, I think you covered most of it. Don't think there's any more thing that you didn't answer.
Yeah, but good questions. Yeah. I think you should mention that like gas fees are kept by MetaMask. No, it's not kept by MetaMask. It's like determined on the blockchain itself. Yeah. MetaMask is basically just like some application to help you like link to the Ethereum network.
Yeah, MetaMask is basically a wallet for cryptocurrencies. So just think of it as your wallet. Yeah, then think of gas fees as like maybe a toll fee. Like when you're driving through a highway, you need to pay some kind of tax to like the highway. So that's kind of like what a gas fee is. So depending on like different highways will have different gas fees, right? So yeah, depending on the rules that govern that highway, or rather that particular blockchain, that's how much gas fee you will have to pay. So in general, it's quite hard to determine how much a gas fee is beforehand. But you will know once you like actually send a request to a contract, and then they'll tell you the gas fee.
Are there any more questions? You can feel free to ask any question. Yeah, we'll try to answer them to the best of our abilities.
Okay, I think if there's no more questions, we'll just end our presentation here then. Yeah, so guys, thanks for coming and see you guys again soon, I guess. Bye-bye.
Yeah, have a good rest of the week.